Hello everybody. Today we will be talking about stacks. The stack keyword that's used in computer science. So a stack is basically an abstract data type or a data structure. So as you know, any data structure should allow you the following operations. Any data structure should give you the flexibility to insert an object into the data structure, delete the object, and should allow you a traversal or a lookup for that particular object. So, like any other data structure, stack 2 allows you the flexibility of performing these operations. So let us see how it does it and what model it follows. So as you know, as I told earlier, stack is predominantly a data structure, and the model it follows is a LIFO model. By LIFO, I mean last in, first out. So as the name suggests, the object which has been inserted in the last position will be the first one to be extracted out. So the stack follows this principle and gives you a data structure which based on these principles. And if you take a look at the stack at the physical layer in the computers, so it's all the data types are stored adjacent to each other. Like say you insert, when you create a stack and insert the first element into the stack, when you create a stack, a pointer is created for when you can insert the first element of the stack. Let's say this is the pointer where you can insert the first element of the stack. So, and let's say after that you insert the first element A. Now you want to insert another element on top of it. So either a B will go over here on top of B, A, or below B. So the stack can go either upwards or downwards, depending on the physical memory that you have. So that cannot be controlled programmatically, but this is how the stack behaves. When you insert an object, it's inserted just adjacent to each other, much like the arrays. So you might have got a feeling by now that stack can be represented as an array. So these are the basic underlying principles of stack. And based on this, we can create an extremely powerful data structure called stack. So we'll learn more about it.
So just one नहीं ठीक है और ऐसे बहुत अच्छा स्पीकर है.
Let me first go a little backwards and start off how stacks originated. Stacks was originally proposed by Alan Turing. He is widely regarded as the father of computer science, and he proposed about this data structure called stack. And stack in computer science is no different from stack in the real world. It's analogous to the stack that we have in the real world. You can find stacks everywhere. In your library, you find a stack of books arranged in such a fashion. Or in your wardrobe, you can find a stack of clothes, your trousers put on top of each other. They are nothing but stacks. So the stacks in computer science is no different from the stacks that you find in real world. Or say you have files kept on top of each other. So the stacks that you deal with in real life is no different from stacks that you deal in computer science. So if you try to find an analogy, this is quite similar. So when you try to insert a book on a particular stack, you have to keep it upwards. And when you are trying to say extract a book out of it, you take a book from the top and then proceed downwards. So that is how the stacks in computer science also behaves. So it's pretty much analogous to the real world stacks that we have. Now we'll go to the stacks implementation in the computer science. In the computer science field.
ये से यहाँ से स्टार्ट करते हैं।
As we had discussed earlier, stacks will either grow upwards or backwards, but the data will always be adjacent to each other. So let's say you have created a stack. You have created a stack and you have, this is the pointer to the first element of the stack, and you add a first element to the stack, A. Now you want to add a new element, B. So you do a push on it and you add it over here. Similarly, you go on adding elements to the stack. After a point, you want to extract the elements from the stack. So a stack gives you the option of extracting the topmost element from its data structure. So you will be able to extract F. At that point, the stack looks like something this. F has been removed, and you can do any kind of manipulations with it, and you have the modified stack with you, which contains elements up to E. Now again you want to do a pop, so you can extract E in the similar fashion, and you get the remaining data structure. Now again say you want to perform an insert. You see that now you have the requirement to insert an element on the stack. So you can similarly insert randomly any element, like say you have a new element called G, and you insert it, and G goes on the top of the stack. So what you see over here is that insertion and deletions are pretty fast. You don't have to do any kind of traversal or lookup or anything of that sort. It's just that you go to a stack, insert it. You go to a stack and delete it. So insertion and deletions are pretty fast. It takes a time of order 1. So this is one of the fastest that you can achieve in any kind of insertion and deletion. Order 1 is considered to be extremely fast, and stack gives you the flexibility of that. So, and the primary operations for any stack is it should allow you to insert an element and delete an element. In computer science world, we call insertion as push and deletion of an element as pop. So any stack should give you these two primary options. You should be able to push an element, you should be able to pop an element, and you should be able to do it in an order 1 time. If your data structure is taking more than order 1 time, it's not a stack. So that is the primary requirement of a stack. On top of it, you can have other utility methods, like say is empty. Let's say you want to check whether the stack is empty before doing a pop, so that you ensure that you don't get any exceptions. So those kind of methods you can define is empty, or maybe get size. You want to understand what is the size of the stack. So this basically constitutes the primary operations of the stacks. Now we'll take a look at how do we go ahead and implement this stack in a programming language of your choice. So we have understood what a stack constitutes of, what are the primary methods of a stack, and what should be the time complexity of the various methods of the stack. Now we go ahead and try to implement it, given the constraints that we have. So the programming language that I will be showing you the implementation in is Java, because I am pretty much familiar with Java. You can choose your own programming language and implement it in a similar fashion. There will be not much of a difference. So we'll go ahead and take a look at how it is implemented in Java.